Good morning, students. I hope you all are well. In the last video, we have introduced the term subspace. Subspace is a subset of the given vector space and it satisfies all the properties of vector space under the operations given in the vector space. Today we will consider the proper definition of subspace, because if we try to verify all the properties, then it is time consuming. So let us define. Let W is a non-empty subset of vector space V. W is called subspace of V if and only if W is closed under addition and scalar multiplication operations defined on V. W is a non-empty subset of vector space V. So W is called a subspace of V if and only W is closed under addition and scalar multiplication defined on V. That means and plausible. So this is a non-empty subset of vector space V, and remember here that means here V is over the field F. Here it is R, the set of real numbers. Okay. So again and again, I will not tell you. Whenever it is given the vector space V, that means the field is given and it is set of real numbers. If any other field is given, then it will be provided to you. So W is a non-empty subset of vector space V. W is called subspace of V if and only W is closed under addition and scalar multiplications operations defined on V. We people know that if it is a vector space, then it will satisfy all the properties, that means all 10 properties of vector space. So this is time consuming. So this is the shortcut if you want to prove that W is a subspace, then you just prove these two properties. Now this one is the closure property of addition. This one is the closure property of scalar multiplication. Remaining 8 properties are inherited from V. Are inherited V itself is a vector space and W is a subset of V. W is contained in V. So, remaining 8 properties are inherited from V. V से W को वो जो प्रॉपर्टीज है वो विरासत में मिली हुई है. तो ये 2 प्रॉपर्टीज का होना जरूरी है. 2 है तो बाकी जो 8 प्रॉपर्टीज है ऑटोमेटिकली इसको प्राप्त हो जाएगी. Here we will prove the identity and inverse for that. So let us see. We know that we have already proved this is a scalar, this is vector, this is also vector, and this is identity. Which type of identity? Additive identity. Okay? For all alpha belongs to V. We know that. This property we know. First one. Second one. We know this property and this property. We have already proved. So we will use this property. Okay? So let us see. Since therefore I just drop this symbol, therefore this is using this. It means the additive identity, people say that is the zero element or zero vector, is also in this subset. And we people know that the identity element is always unique. So whatever the identity element of vector space will be the identity element of its subspace. Very important property. Similarly, let say -1. Then because scalar multiplication is closed in W, this is and this is, therefore there is an element minus alpha belongs to W such that so minus alpha, or you can say So there exists identity element, there is the inverse element, and remaining properties are inherited. You can prove them from the vector space. So here you have to remember the identity element, that means the additive identity of the vector space will be the same additive identity of the subspace. Okay. Now let us consider some examples on this. Let V is R2, that is belongs to R, three-dimensional space. V is this. This is the vector space under standard regular. Several times I have repeated standard or regular. Addition and scalar multiplication. Component wise. This is the vector space under standard addition and scalar multiplication, and here it is known as component wise. Sometimes it is written like this in terms of column matrix, like this, maybe written like this. This is a column matrix. Or may be given in terms of row matrix. Transpose of this will be this. Okay, so be careful. Some authors write this way, some in this way or this way, whatever it is. But you just remember, this is the triplet. You can consider n-dimensional space, that is n people or ordered space, but we people know that the situation is like this. Okay, so we know that. Let W equals to this belongs to our kit, and here y equals to 0, or I can write what is the geometry of this? Y coordinate is 0, that means this is Z. Okay. So obviously this is a subset of P. Now we prove that this is a vector space. Okay, so let's W1 equals to x1 comma 0 comma z1, W2 equals to x2 comma 0 comma z2. Now closure property. Component wise addition, so it is x1 plus x2 0 and this is z1 plus z2. Definitely this is a real number, so I can say suppose it is a 0 and here it is b. B is z1 plus z2. Okay, and this belongs to W. Therefore, is closed. Let C belongs to R. Now, and this belongs to W. Therefore, is closed. So W is closed under addition as well as scalar multiplication defined on the vector space V, which contains W. That means W is a subset. Hence W is subspace. Okay. If we consider geometrically, then we see this is z. Okay, so z plane, that means it passes through the origin, that means 0 comma 0 will be the additive identity. So this plane is passing through this one. Now instead of this one, if I change the example, then what will happen? Let V equals to R and W equals to X 3 and Z. X, Z belongs to R, or you can write X, comma, Y, comma, Z belongs to cube such that y equals to 3. Okay, so let w1 equals to x1 3 z1 and w2 equals to x2 3 z2. Therefore w1 plus w2 equals to x1 plus x2 and this is 6 z1 plus z2. It looks like A6B, where A is x1 plus x2 and B is z1 plus z2. Okay, and this does not belong to W because here the number 6 you can see. Therefore, is not closed. Therefore, W is not a subspace. Okay, and if you look at the geometry, then you find, I draw this diagram. Suppose this is 1 unit, this is 2 unit, and this is 3 units. So it is just similar to this. Find this type of situation. It is this way. This is ZX plane, and this is its equation is y equals to 0, and this one is y equals to 3. Here it is y equals to 0. So it is 3 units away from this one, and it is not passing through the origin. It is not passing through the origin. That means identity absent. So without doing this one, sometimes this question is given in multiple choice in competitive examination, and you have to find what is going on. So you find this is the ZX plane, this is the plane which is at a distance of 3 units parallel to this plane. That means it is not passing through the origin. Origin is not included in this one. That means identity is absent, and identity is absent. So this is not a subspace. Okay, so this type of situation you can consider. Let us discuss one more example. Let V equals R square. That is x comma y, xy belongs to R. Geometrically, you know that this is xy plane. Represents a set of all points in xy. Okay. W equals to C. I hope you can answer immediately. This is the xy plane. The complete xy plane is represented by this, and W, that is x comma 0. So y coordinate is 0. That means it is x-axis, and we people know that. Here it is. It is this one. This is any point you can consider. 0 is also included. So definitely this is a subspace. Similarly, suppose this is W1, I say W2 equals to 0, comma y, for example, and y belongs to R. Then what will happen? To find it is this line because x coordinate is 0. Here it is the origin, so this is also a subspace. Okay, you remember W1 is a subset of V, W2 is a subset of. Now very important note, I write it here. W1 union W2. This is x comma y such that x equals to 0 or y equals to 0. X y belongs to R. So either x equals to 0 or y equals to 0. This is the union of this one, and if I consider, then you find answer is these two lines together, and here it is. Okay, this is suppose I say it is W1 for example, and this is W2. Let 1, 0 belongs to W1 and 0, 1 belongs to W2. Okay, so look at this. This is 1, 0, and here you find this is 0, 1. And if we add 1, 0, then it is component wise, so it is 1 plus 0, 0 plus 1. And this we find 1, 1. And this is not the member of W1 union W2. Because this contains either the point on this line or this line. And graphically, if you find the answer, then here you see, here it is the point. This is 1, 1. So the W1 is the set of all points lying on x-axis, and W2 will be the set of all points lying on y-axis. X-axis and y-axis be the part of xy plane. So W1 is the subspace of V, W2 is the subspace of also V. But if you find W1 union W2, then you will find this type of a situation. So the union of these two subspaces is not a subspace of V, but instead of union, if I consider the intersection, then intersection will include only the single point. That means it is this. And we people know that this is a null space, because it is non-empty set. So you people know that there are two standard or trivial subspaces. One is null space and other one is the vector space itself. Okay, so it is this type of situation. Now you try yourself. Let's V equals to R square and W equals to, suppose I say it is A plus 1, for example, and A belongs to R. Then determine whether W is the subspace of V. With R square and W is given by this, determine whether W is a subspace of V. If you look at this question, then you can find the answer immediately, but you write the answer with the proper reason. So if you have difficulty, then you comment in the comment box. You just revise what is going on. Okay, so thank you very much. God bless you.